All right, let's put you in the driver's seat. You're the senior architect, and you've got this one massive job: tame the multi-cloud spending beast. Your tools aren't just dashboards anymore. Today, we're going to architect a system that uses machine learning to go way beyond just reporting what you spent and start predicting with some serious accuracy what you will spend. Seriously, just imagine this for a second. You walk into your next budget meeting and you tell the CFO not what you think you'll spend, but what the data says you're gonna spend, with a clear margin of error. Think about that. No more painful surprises, no more wild guessing games, and definitely no more emergency budget shuffles. That's the power of predictive FinOps. But before we get to that crystal clear future, we have to deal with the reality of right now. And the reality is, multi-cloud billing is a total nightmare. Each provider, AWS, Azure, GCP, they've all got their own way of doing things, their own billing structures, their own data formats. Trying to piece all that together by hand is just a recipe for disaster. And this chart right here, this is exactly what that disaster looks like. See that huge out-of-nowhere spike on the AWS bar in Q1? That was a new data-heavy project. Then, bam, in Q2, Azure suddenly jumps because compute demand went through the roof. This kind of volatility is just the name of the game in multi-cloud, and it's precisely why you need a much, much smarter way to forecast your costs. The old ways, especially our good friend the spreadsheet, they just can't keep up. For example, your spreadsheet might predict a simple, 10% cost bump for your e-commerce site in November. But then you have a crazy successful Black Friday campaign, and suddenly compute usage spikes by 400% for 3 days straight. A static, formula-based model just completely falls apart under that kind of real-world pressure. So what's the solution? We need to build a kind of financial GPS for your cloud. And no, it's not magic. It's a machine learning system that is constantly watching your spending, learning the normal rhythm of your business, spotting trends, and, most importantly, warning you about potential problems long before they blow up into catastrophes. The big shift here, the real game changer, is moving from being reactive to being proactive. It means instead of getting to the end of the month and discovering you've overspent, again, you get an alert in week 2 saying, hey, you're on track to go over budget. This gives you actual time to figure out what's going on and fix it before it's too late. Okay, so let's roll up our sleeves and get into the nitty-gritty. How do we actually build this system? We're going to walk through the whole blueprint, from grabbing the right data and cleaning it up to picking the right model and training it to make those super accurate predictions. So the core ML pipeline really boils down to 3 key steps. Get the data, find the patterns, and then train the model to predict. Looks simple on a slide, right? Well, you know what they say, the devil is in the details. In the next few slides, we're going to dive deep into each one and talk about the real challenges you're going to face. Let's start with the first and honestly, probably the hardest one, getting the data. First things first, you have to ingest all your billing data from AWS, Azure, and GCP. And as you can see, each one gives it to you in a different format. Normalizing this data is a huge undertaking. We're not just talking about matching up column names here, we're talking about defining a single, unified way of looking at everything. How do you consistently define a vCPU hour or a GB month of storage across all 3 platforms? Getting this unified data model right is absolutely essential. If you don't, the whole thing falls apart. Okay, once your data is all clean and unified, you can start modeling patterns. And the first and most important pattern is seasonality. If you're an e-commerce company, you know traffic is going to spike during the holidays. If you're a gaming company, usage is going to jump every Friday night. Your model, especially a time series model like Arima or Facebook's Profit, has to learn these repeating cycles to make any kind of accurate baseline prediction. But just looking at the calendar isn't enough. You have to dig deeper to understand the drivers behind those costs. This is where you start correlating your billing data with other business metrics. For example, maybe you pull in data from your CI/CD pipeline and discover that a new feature deployment directly caused a spike in database reads. Once you find these drivers, you can build a model that understands things like, for every 1,000 new users we sign up, our database costs will go up by this predictable amount. Now, predicting your bill is great, for sure, but it's not really enough, is it? You also need the power to spot weird things in your spending in real time. This is where your system goes from just a strategic planning tool to an immediate operational control center. Because even the absolute best forecast in the world can't predict a developer accidentally spinning up a massive and massively expensive GPU cluster for some side project. To catch that, you need anomaly detection. In practice, this means your model creates a normal range of expected cost for any given hour. The second your real-time usage suddenly jumps outside that band, it triggers an alert. And this quote just nails it. The real power here is catching those mistakes before they turn into a 5 or 6-figure line item on your bill. For instance, you could set up an alert that pings you anytime a developer creates a new resource without the right cost allocation tags. You catch that governance mistake in minutes instead of finding some huge untraceable cost on your bill weeks later. So forecasting and anomaly detection are really two sides of the same coin, and they work together beautifully. Forecasting helps you plan for the future by predicting what should happen. Anomaly detection helps you react to the present by flagging when things are not going according to that plan. They create this awesome feedback loop. The forecast sets the baseline for what's normal, and any anomalies you detect can be fed back into the model to make future forecasts even smarter. So we've talked a lot about the how. Let's talk about the so what. What is the real-world impact of actually building a predictive FinOps system? Let's get into some of the tangible benefits you can expect to see, from killing budget surprises to actually empowering your engineers. The business outcomes here are genuinely transformative. You can flat out eliminate budget surprises with alerts that tell you when you're trending to go over. You can justify new cloud projects with cost projections backed by actual data. And maybe best of all, you can create a real culture of cost awareness by giving engineers tools that show them the financial impact of their code before it ever even gets to production. Ultimately, the goal is to build one system, a single source of truth for all of your multi-cloud spending. This system ends all those arguments between finance, ops, and engineering because now everybody is looking at the same trusted, intelligent data. It completely changes the conversation from who's to blame for this overage to how can we innovate more efficiently together. The crazy thing is, the data you need to predict the future, it's already there. It's sitting in your billing logs right now. It is a detailed roadmap of your company's entire operational past. It is time to put that data to work. Start building your predictive FinOps system and turn that historical roadmap into your financial GPS for the future.